Good afternoon, one and all. Today we will going to discuss to start the unit number 6 antenna and its application. Based upon that, we have seen the next very important type of the antenna and its application, that is the rhombic antenna. Rhombic antenna is basically an equilateral parallelogram shaped antenna, and generally it has the two opposite actuate angle, and the tilt angle theta is approximately equal to 90 degree minus the angle of the major lobe, and the rhombic antenna works under the principle of travelling wave radiator. It is arranged in the form of the rhombus or the diamond shaped, and the actually it is the suspended horizontally above the surface of the earth, and it is operated in the 3 megahertz to 300 megahertz. Means this antenna work in the high frequency and very high frequency ranges. Here is the construction of the rhombic antenna. Here is the feeder from the transmitter. Here is to place the transmitting antenna, and here is the terminal. There are the different terminals which is to be able to receive the antenna, and it is to be designed basically the central. This is the azimuth of the main beam of an antenna, which is diverted in this way, and it is the terminal dissipation line, which is called as the terminal dissipation line. The rhombic antenna can be regarded as the two V-shaped antenna. If this is the one V-shaped antenna, and here is the another V-shaped antenna, it's basically it is the combination of the two V-shaped antenna. This the V type of the antenna we will going to discuss in my next video. A rhombic antenna can be regarded as the two V-shaped antenna and connected end to end form the obvious angle due to its simplicity and easy of the construction. It has many uses in the high frequency transmission reception communication, that is point to point communication. The two sides, basically these two sides, the two sides of the rhombus are considered as the conducted of the two-wire transmission line. Here is the two-wire transmission line. When this system is properly designed, there is a concentration of the radiation along the main axis of the radiation. In practice, the half of the power is dissipated in the terminating resistance of an antenna. Then the rest of the power is radiated, or the wasted power is contributed to the minor lobes. Then in the figure 1, it is the actual construction of the rhombic antenna for point-to-point communication in the olden days. But in the figure 2 shows the rhombic UHF antenna. In nowadays, in the TV reception, it is used of this nowadays. Then the maximum gain from the rhombic antenna is along the direction of the main axis, and which passes through the feed point to the terminate in the free space, and the polarization obtained from the horizontal rhombic antenna, and it is the plane of the rhombus which is horizontal. This is the radiation pattern. Very fantastic way to show the radiation pattern here. Basically there are the two transmission line, and in the two transmission line there is a resistance is connected between them, and this is the unidirectional, not a bidirectional. This is the unidirectional of the antenna in the respective planes, and the resultant radiation pattern on the rhombic antenna is shown in the figure. It is the cumulative effect of the radiation of all four legs of an antenna, and this pattern is the unidirectional, and which it can be made in the bidirectional by removing the terminating resistance. Then its advantages is that the input impedance and the radiation patterns are relatively constant. The multiple rhombic antenna can be connected in simple and effective transmission line. The disadvantages is that it a wastage of the power in the terminating resistor, then requirement of the large space reduce the transmission efficiency. Its application is that it is used in the high frequency communication, it is used in the long distance skywave propagation, used in point to point communication, etc. Thank you very much.